প্রদীপ্ত, আমার কথা শোনা যাচ্ছে?
হ্যাঁ, আমার কথা?
হ্যাঁ, পরিষ্কার।
আচ্ছা, ঠিক আছে। আমার কথা?
প্রদীপ্তা,
হ্যাঁ, বলো।
তোমাদের এই স্পিকারদের নামগুলো আরেকবার বলে দাও। নবেন্দু কর, তাই তো?
হ্যাঁ, প্রথমে হলেন ডক্টর লক্ষ্মীনারায়ণ সৎপতি।
বেশ।
আচ্ছা, তারপরে হলেন মিস্টার নবেন্দু শেখর কর।
নবেন্দু শেখর কর, আর তারপরে
ডক্টর সায়ন্তন দাস।
ওকে, নবেন্দু শেখর করকে আমি ঢুকিয়ে নিচ্ছি।
হ্যাঁ হ্যাঁ হ্যাঁ
এনএসকে বোধ হয় না?
হ্যাঁ, এনএসকে, হ্যাঁ, নবেন্দু শেখর কর।
জিজ্ঞাসা করে নাও, উনি ঢুকছেন। এনএসকে নামে ঢুকছেন, ওই জন্য জিজ্ঞাসা করি।
পার্থ, সব ঠিক আছে?
মোটামুটি। মধুসন্ধ্যা?
হুম।
হুম হুম হুম, মোটামুটি। প্রচুর তোমাদের এখনই পার্টিসিপেন্ট প্রচুর হয়ে গেছে, আমি কাউকে করছি না, অ্যাডমিট করছি না।
কাল তো দেখলাম মেলেই অনেক হয়ে গেছে।
আছে টোটাল মোটামুটি
টোটাল 360 জনকে কালকে মেল করা হয়েছে, মানে তার মধ্যে আমরা সবাই আছি।
হ্যাঁ হ্যাঁ হ্যাঁ, মেল পেয়েছি তো কালকে।
Before imaging the A point with the base, it will image the B point, the top. Therefore, it appears like
নমস্কার অধ্যাপক কর, ওয়েলকাম।
overlaying.
নমস্কার।
আমি ওটা দেখেছি।
এখনো ফারুক ঢুকছে না কেন?
ল্যাপটপ জোগাড় হলো নাকি এটা ফোনেই?
কি বলছো
আওয়াজ আসছে না,
মধুসন্ধ্যা?
তুই আনমিউট কর নিজেকে। নিজেকে আনমিউট কর।
কার কথা বলছিস?
না, ও আনমিউট করতে পারবে না, আমি আনমিউট করব।
করতে পারবো না।
হয়েছে।
হ্যাঁ, এবার হবে। হোস্ট যতক্ষণ না আনমিউট করবে আমি তো পারবো না। না রে, ল্যাপটপে বসছি না, রিস্কটা নিলাম না।
ফোনেই?
হ্যাঁ, ফোনে। কে কে আছে?
ফারুককে পাচ্ছি না।
পার্থ মধুচন্দ্র প্রদীপ এনএসকেটাকে।
ইনিসকে স্যার স্যার
ও
অধ্যাপক নবেন্দু শেখর পর।
ও হ্যাঁ হ্যাঁ হ্যাঁ, উনি এসে গেছেন।
তুইও দেখেছিস
কোথায় বলতো?
টেডি ব্রেবন কলেজে একটা ওয়ার্কশপ হয়েছিল মনে আছে?
হ্যাঁ।
সিআইএস শিখিয়েছিল।
ও তুই ইয়ে করছিস না কেন? ভিডিও অন
করছি না,
কর, ভিডিও অন
দরকার
কর।
আছে থাক।
তোকে একবার দেখি, কতদিন দেখি।
না না না, একদম না।
একবার অন কর,
না
তুই আবার অফ
না
করে দিবি, তুই আবার অফ করে দিবি, একবার অন কর
না
তুই।
না।
এই
আচ্ছা এখন
এই
তো কেউ আসেনি।
খুরশিদা
এই পার্থ
খুরশিদা
করবে না, পার্থ পার্থ
খুরশিদা
প্লিজ করুন।
খুরশিদা
বলো
খুরশিদা
বলো।
মধুচন্দা
হ্যাঁ বলো।
ইউটিউব স্ট্রিমিং কিন্তু শুরু হয়ে গেছে, হচ্ছে কিন্তু।
মা তাই নাকি?
হ্যাঁ,
ও তাহলে
উপরে লেখা
করে
আছে
দাও।
দেখো।
তাহলে তুমি
হ্যাঁ
আমাকে, আচ্ছা আমি নিজেকে মিউট করতে পারবো?
হ্যাঁ পারবে।
হ্যাঁ মিউট করলো তো। হ্যাঁ ইউটিউবটা এখন শুরু হলো কেন? সারাদিনটাই হবে না?
ফারুক যে কেন এখনো জয়েন করছে না।
ভিডিওটা একবার ক্যামেরাটা অন করে দেখি আমার ল্যাপটপে ঠিক মতন ঠিক আছে না এবার?
হ্যাঁ ঠিক আছে তো।
আচ্ছা আপাতত অফ থাক, শুরু হলে আবার অন করবো।
হ্যালো ঘোষিদা,
হ্যাঁ বলুন।
আমার কথা পরিষ্কার শোনা যাচ্ছে?
হ্যাঁ
হ্যাঁ
পরিষ্কার
স্যার,
শোনা যাচ্ছে।
শোনা যাচ্ছে পরিষ্কার।
আচ্ছা আচ্ছা, ঠিক আছে ঠিক আছে।
ফারুক, এই যে ফারুক এসছে।
এসছে?
হুম। ফারুককে জয়েন করানো গেল কোথায়? এখন জয়েন হচ্ছে। ফারুকের নেটওয়ার্কের এত প্রবলেম,
প্রচন্ড
ভাবা যায়
প্রবলেম,
না।
ওকে ফোন করলেই তো পাওয়া যায় না, খুব প্রবলেম।
কতক্ষণ আগে ওকে জয়েন করিয়েছি, এখনো জয়েন করছে। জাস্ট নামগুলো ঢুকলো।
ও
বাড়ির খবর সব ঠিক আছে?
হ্যাঁ আপাতত ঠিক আছে।
ওয়েলকাম ফারুক।
মিউট হয়ে আছে।
ফারুক, ফারুক শোনা যাচ্ছে তো? হ্যাঁ ফারুক, অধ্যাপক কর জয়েন করে গেছেন অলরেডি।
হ্যাঁ, বাকিদের সঙ্গে কথা হয়েছে, ওরা তাড়াতাড়ি জয়েন।
মাইকটা কাজ করছে না তোমার ঠিক মতো?
বলেছি কিন্তু জয়েন, দেখা যাক। শুরু হয়নি কথা।
আমিও তোমার কথা খুব অল্প শুনতে পাচ্ছি, খুব আস্তে শোনা যাচ্ছে, যার জন্য বুঝে বুঝে উঠতে পারছি না ঠিকঠাক।
এখনো রিকোয়েস্ট সেরকম আসছে না।
কি রিকোয়েস্ট আসছে না? ফারুক আবার নিজেকে মিউট করে নিয়েছে। Farooq, please unmute yourself. ফারুক শোনা যাচ্ছে? কৌশিক দাস। হ্যাঁ, কেটে কেটে আসছে, তোমার কথা ভীষণ ভাবে কেটে কেটে আসছে।
না ফারুক কই কথাগুলো
ঠিক
শুনতে
আছে।
পাচ্ছ ঠিকঠাক?
তুমি আমাদের কথা ঠিকঠাক শুনতে পাচ্ছ ফারুক?
আমি শুনতে পাচ্ছি, আমি শুনতে পাচ্ছি, কিন্তু আমার কথা শোনা যাচ্ছে না কোনোভাবে।
স্যার গোপাল বাবুর সাথে কথা হয়েছিল তো?
হ্যাঁ
গোপাল বাবুর সাথে কথা হয়েছিল তো? উনি
হ্যাঁ,
এখনো ঢোকেননি
সকালে
কিন্তু।
সকালে কথা আজকে সকালে হয়নি, কালকে রাত্রিবেলা তো অনেক কথা হলো অন্য ব্যাপারে, কিন্তু সকালে আমার সঙ্গে কথা হয়নি।
প্রদীপটা কি মিউট হয়ে গেছো? না, প্রদীপটা
না
আছে।
না, আছি আছি।
ওকে। ফারুকের সিগন্যালটা আজকে যেন বেশি বেশি গন্ডগোল করছে, অন্যদিন তবু একটু একটু শোনা যায়।
এই একটা সমস্যা, মানে অনলাইন ওয়েবিনারে এটা মেইন সমস্যা।
আচ্ছা, এলএনএস আসছেন, এলএনএস
আচ্ছা
কে জয়েন করাচ্ছে।
আচ্ছা। ডক্টর সায়ন্তন দাস আসবেন আমাদের আরেকজন স্পিকার।
সায়ন দাস, তাই তো?
সায়ন্তন দাস।
আচ্ছা, উনি কোথায় এখনো আসেন? আসলে স্পিকারটা যতক্ষণ না জয়েন করেন খুব এতে
হ্যাঁ
থাকি
হ্যাঁ,
আর কি।
নিশ্চয়ই নিশ্চয়ই।
এলএনএস এসে গেছে?
হ্যাঁ স্যার
এলএনএস এসে
এসছেন,
গেছেন।
স্যার এসছেন।
আমি স্যারকে একটু আনমিউট করছি।
হ্যাঁ হ্যাঁ।
ওয়েলকাম ডক্টর শতপথী। ফারুক নিজেকে আবার মিউট করে নিয়েছে। ফারুক আনমিউট করো। ফারুক আনমিউট ইয়োরসেলফ।
আমি আনমিউট করছি বারবার, কিন্তু আবার চলে যাচ্ছে।
হ্যাঁ, এখন একটু শোনা যাচ্ছে, এখন একটু শোনা যাচ্ছে। এলএনএস
স্যার
এন্টার করে গেছে। হ্যাঁ, এলএনএস চলে এসেছেন।
ওয়েলকাম স্যার। একটু প্রবলেম হয়তো হচ্ছে, আমাদের টেকনিক্যালি একটু প্রবলেম। হ্যালো
ডক্টর শতপথী প্লিজ আনমিউট করবেন।
স্যার। স্যার শুনতে পাচ্ছেন নাকি?
হ্যাঁ স্যার, একটু কথা বলুন স্যার।
হ্যালো হ্যালো, শোনা যাচ্ছে?
হ্যাঁ
হ্যাঁ, শোনা যাচ্ছে পরিষ্কার।
ওকে।
হ্যাঁ শোনা যাচ্ছে। ওয়েলকাম স্যার।
তাহলে ফারুক আর ডক্টর দাস জয়েন করলেই মোটামুটি আমাদের স্পিকাররা সবাই চলে আসবেন।
আচ্ছা, বাংলায় বলবো না ইংরেজিতে বলবো?
স্যার একটু চেষ্টা করেছি ইংরেজিতে বলতে, ইন্ট্রোডাক্টরি স্পিচ একটু ইংলিশে বলতে চেষ্টা করেছি স্যার।
তাহলে তাই হবে।
গোপাল বাবু ঢুকছেন।
পার্থ কতজন এসছে পার্থ?
হ্যাঁ স্যার, গোপাল বাবু এলেন। ডক্টর
না,
দাস
কতজন এসেছে, কতজন এসেছে এখন?
এখনো 60।
আচ্ছা,
যেদিকে স্যার শোনা যাচ্ছে। গোপাল বাবু শোনা যাচ্ছে?
হ্যাঁ 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 শোনা যাচ্ছে। হ্যাঁ শোনা যাচ্ছে।
ওকে ওকে, ঠিক আছে।
এই তো এই ডাউন করে ও আচ্ছা আচ্ছা। এই যে ভিডিও এই যে
ফারুককে আনমিউট করছি, ফারুক কি করে মিউট হয়ে যাচ্ছে?
হলো পার্থদা,
হ্যাঁ ফারুক, শোনা যাচ্ছে, বলো।
এতক্ষণ হলো। আচ্ছা, কতজন এসছে আমাদের মোটামুটি এখনো পর্যন্ত?
স্টিল ওই 70, অ্যারাউন্ড 70।
70, এখনো 5 মিনিট বাকি আছে।
হ্যাঁ, এখনো 5 মিনিট বাকি আছে। হচ্ছে না, অনেকেই হচ্ছেন।
রিসোর্স পার্সনরা সবাই এসে গেছে পার্থ?
না, একজন
না,
আসেনি।
একজন এখনো বাকি আছেন, ডক্টর দাস বাকি আছেন।
সায়ন্তন দা আসেনি, ও ঢুকবে, ঢুকছে একটু পরে, ঢুকছে বললো।
অ্যাকচুয়ালি ফিল আপ হয়ে গেলে তখন না আমি অ্যাডমিট করানোটা খুব মুশকিল হয়ে যায়।
পরের দিকে হলে তো আর 5 মিনিট আছে, পরে 100 জন
একটু
হয়ে গেলে
সমস্যা।
মুশকিল হয়ে যাবে পরে।
তখন অ্যাকচুয়ালি ওয়েটিং রুমটাও ভরে যাও, তো ফলে উনি আর ঢুকতেই পারবেন না, এরকম একটা জায়গা তৈরি হয়ে যায়।
আচ্ছা, প্রদীপ্তা ম্যাডাম আছেন তো? ওনার ওখানে
হ্যাঁ,
টেকনিক্যালি কোনো প্রবলেম হচ্ছে না তো, নেটওয়ার্কের কোনো
বলো।
সমস্যা?
প্রদীপ তো একবার কথা বলে
না,
নিন তো।
আপাতত প্রবলেম হচ্ছে না, সাউন্ড চেক
না
হয়ে
ঠিক আছে,
গেছে পার্থর সঙ্গে।
একদম একদম
ঠিক
একদম
আছে, হ্যাঁ,
পরিষ্কার তো।
ক্লিয়ার আছে, সাউন্ড
তুমি
ক্লিয়ার।
প্রদীপটা একটু ভিডিওটা অন করো তো, তোমার
হ্যাঁ,
ভিডিওটা শুদ্ধ,
ভিডিওটা
সাউন্ডটা একবার দেখে নিই।
দেখো, ঠিক আছে, শোনা এবং দেখা যাচ্ছে তো প্রপারলি?
হ্যাঁ, প্রপারলি,
হ্যাঁ,
ঠিকঠাক।
প্রপারলি দেখা যাচ্ছে, ঠিক
ওকে
আছে।
ওকে।
তো ফারুক,
হ্যাঁ স্যার,
বলছি তুমি ওই সায়ন্তন বাবুকে একবার ফোন করবে?
আমি ফোন করেছি, ও ঢুকছে, এক্ষুনি ঢুকবে বললো।
আচ্ছা আচ্ছা, ঠিক আছে ঠিক আছে।
এক্ষুনি 3:30 নাগাদ ঢুকবে বললো।
ও মাই, আচ্ছা তাহলে ঠিক আছে।
কত হয়েছে?
75।
তুমি বলো ঢুকে যেতে, এক্ষুনি আরেকবার বলে দাও, পার্থর পক্ষে অসুবিধা হয়ে যাবে।
হ্যাঁ, আমি বলছি, আবার বলছি। পার্থদা কত হলো? টাইম তো অলমোস্ট শেষ।
85।
3:29, একদম মানে শুরু হওয়ার সময় চলে এলো। ঠিক আছে, আমাকে সায়ন্তন দা বললো ঢুকছে।
উনি ঢুকে গেলেই আমরা শুরু করে দেবো।
হুম।
ফারুক এখন কিন্তু তোমার সাউন্ডটা ঠিকঠাক আছে,
আমি একটু
একদম
বাইরে
ঠিকঠাক
থেকে
আছে।
এলাম,
ওকে ওকে।
আমার ঘরের মধ্যে তো প্রবলেম হচ্ছে।
ফারুক এবারে আমি আর অ্যাডমিট করতে পারবো না।
কত হলো?
90।
সায়ন্তনকে আরেকটা ফোন করে দেখো।
দেখছি একটু দেখছি।
আচ্ছা, it's 3:32, so let's start. Pradipta.
আচ্ছা, hello everyone and good afternoon. I am Pradipta Mollik, faculty member of Department of Geography, Shohid Anuruddh Chandra Mahavidyalaya, welcoming you all to our today's session. Greetings to all of you for taking some time out and attend our today's national level webinar. It is organized by Department of Geography in collaboration with Internal Quality Assessment Cell of Shohid Anuruddh Chandra Mahavidyalaya. India is highly vulnerable to natural hazards, especially earthquake, floods, drought, cyclones, and landslides. Studies indicate that natural losses equate up to 2% of India's GDP and up to 12% of central government revenue. The cyclones that occur between Tropic of Cancer and Tropic of Capricorn are generally known as tropical cyclones. Tropical cyclones are weather systems in which wind equals or exceeds minimum of 62 km per hour. Indian subcontinent is worst affected region in the world, having a coastline of 7,516 km, and it is exposed to nearly 10% of the world's tropical cyclones. The east coast of India and the coastlines of Bangladesh, Myanmar, and Sri Lanka are vulnerable to the incidence of tropical cyclones of Bay of Bengal. Cyclones occur in the months of May, June, and October, November. Every year, these cyclones inflict heavy loss of life and properties in this region. Global climatic change resulting from anthropogenic activities is likely to manifest itself in weather and climate of Bay of Bengal region. The result of the trend analysis revealed that the severe cyclonic storm frequency over Bay of Bengal has registered significant increasing trend through decade after decade. Recurring cyclones account for large number of deaths, loss of livelihood opportunities, loss of public and private properties, and severe damage of infrastructure. Climate change and its resultant sea level rises can significantly increase the vulnerability of coastal population. In light of this present atmospheric situation, we have chosen the main theme of our today's national level webinar. So the main topic for today's webinar is increasing frequency of tropical cyclone and its impact on coastal Bengal. To discuss over this topic, we have today eminent personalities of international repute. Today we have with us Professor Dr. Lokhinarayan Shatpathy, Department of Geography, University of Calcutta, and Honorary Director, UGC, Human Resource Development Center, Calcutta University. Welcome, sir. Mr. Nobendu Shekhar Kaur, Assistant Professor, Department of Geography, Shohid Matongini Hajra Government College for Women. Sir, welcome. And Dr. Shayantan Das, Assistant Professor, Department of Geography, Dom Motijhil College. Dr. Das will be with us in any moment. Now, the welcome note for today's webinar will be given by IQAC coordinator of our college, Professor Nimai Poddar. Sir.
Thank you, Pradipta. Good afternoon, everybody present in this platform. It is my great pleasure and honor to welcome you all at this national webinar organized by the Department of Geography and IQAC of our college. Before we begin this webinar, I would like to express my heartfelt gratitude to all of you who sincerely committed to this event to make a success. And it would have been impossible to organize this webinar without the support of each and every one of you join in this webinar. I sincerely welcome our distinguished resource persons in today's webinar. Firstly, I convey my warmest welcome to Dr. Lokhinarayan Satpathy, an eminent scholar in the Department of Geography, Calcutta University, and Honorary Director, UGC, Human Resource Development Center, Calcutta University. I also welcome Dr. Sayantan Das, Assistant Professor in Geography, Dom Motijhil College, and Mr. Nobendu Shekhar Kaur, Assistant Professor in Geography, Shohid Matongini Hajra Government College for Women. I also convey my heartiest greetings and warm welcome to our respected participants who joined this webinar from different colleges and universities of our country, and our colleagues and our beloved students. The theme of many of such webinars in present time is centering around the COVID pandemic situations because of its all-pervasive impact on the life and society. The topic that has been chosen for today's webinar is completely from the core subject area of geography, and it is also very much relevant in the context of recent cyclonic storm Amphan. I thank Professor Farooq Mollik, Head of the Department of Geography, and other faculty members of the department for choosing this theme for academic discussion. As we all know, the east coast of India and the coasts of particularly Bangladesh, Myanmar, and Sri Lanka are vulnerable to these tropical cyclones of Bay of Bengal. Some data shows about 80% of these cyclonic storms of North Indian Ocean form in the Bay of Bengal. On an average, about 5 to 6 tropical cyclones form in the Bay of Bengal every year, and of which about 2 may reach to severe stage. And today's webinar, we will discuss the geographical causes of the increasing frequency of these tropical cyclones and its impact on coastal Bengal. So, and for this discussion today, we have with us Dr. Satpathy, sir, a very experienced scholar in the field of geography, and 2 other distinguished resource persons from the same field. Many of us present here in this webinar today had the opportunity of listening to Dr. Satpathy as Director of HRDC CU, but in today's program, we have the opportunity to enlighten us from his field of expertise. Dr. Satpathy authored numerous articles in reputed journals and books. Many research scholars have finished their PhD and MPhil degrees under his scholarly supervision. And today, we have also with us two other distinguished resource persons, Dr. Das and Mr. Kaur, who will jointly present a comparative study of two present or recent cyclonic storms, Amphan and Ayla. Hope this presentation will also be an interesting event of this 2 days webinar. Hope will be an interesting session ahead. With these few words, I conclude and again welcome you all and thank you very much for joining with us in this afternoon. Thank you.
Thank you, Professor Nimai Poddar sir, for your warm welcome address. Now, I would like to request respected teacher in charge of our college, Professor Gopal Dept.of sir, to say a few words for us. Sir.
Good afternoon, everyone. At first, I would like to thank Professor Farooq Mollik, Head Department of Geography, and Professor Nimai Poddar, Senior Most Teacher of our college, and the IQAC Coordinator for organizing this national level webinar on increasing frequency of tropical cyclone and its impact on coastal Bengal. I also welcome our resource persons, Dr. Lakshminarayan Satpathy, Professor Nabendu Shekhar Kaur, and Dr. Sayantan Das. Professor Nimai Poddar and Professor Promita Mukherjee said, I just add some points. Number one, I want to say, analyze data for the period 1980 to 2000 shows that on an average annually, 370 million people are exposed to cyclone in India. Cyclones occurs in the month of May, June, and October and November, with primary peak in November and secondary peak in May. We remember Ayla occurred in May 25, 2019, and recently Amphan occurred on May 20. Lastly, I want to say that although cyclones affected the entire coast of India, the east coast is more prone compared with the west coast. An analysis of the frequency of the cyclones of the east and west coast of India during 1871 to 2000 show that nearly 308 cyclones, out of which 110 were severe, affected the east coast. During the same period, 48 tropical cyclones crossed the west coast, of which 24 severe cyclone storms. Lastly, out of cyclones that developed in the Bay of Bengal, over 58 approached and crossed the east coast in the October and November. Only 25% of the cyclone that developed over the Arabian Sea approached to the west coast. In the pre-monsoon season, corresponding figures are 25% of the Arabian Sea and 30% over the Bay of Bengal. Professor Promita Mukherjee rightly pointed out, I just add one or two points. Recurring cyclone account for large number of deaths, loss of livelihood, property, opportunities, loss of public and private properties, and severe damage of infrastructure. Thus, seriously the development gains of the regular intervals. Secondly, broad scale of assessment of the population at risk suggests that an estimated 32 crore people, which accounts for almost third of the country's total population, and vulnerable to cyclone related hazards. Climate change, rightly point out Professor Professor Mukherjee, and its resultant sea level rises can significantly increase the vulnerability of the coastal population. Thank you all.
Thank you, sir, for your kind words. Now, let us move forward to our main session. So before going that, a small announcement to all the participants. If you have any questions during the presentation, please keep a note. We will going to have a separate question answer session at the end. So today we have Professor Dr. Lokhi Narayan Shatpathy, sir, Department of Geography, University of Calcutta, and Honorary Director, UGC, HRDC, University of Calcutta. Sir, going to you, sir.
Thank you. Let me allow to share the screen. It is disabled from your side. Hello?
Yes, sir. Wait.
Okay. Okay.
I'm giving you. Yes, sir. Share your screen.
Okay, okay. So now it can be done. I think you can see it now. Is it visible and am I audible? I think I am audible.
Yes, sir. Sir, you are audible, sir. But
and the PowerPoint is visible also.
Sir,
No, sir.
we cannot see the screen, sir, actually.
Can you see the screen?
No, sir.
Okay. Screen sharing has failed to start. Please try again. Error. Why there is error? There is some
Sir, please
problem.
try again.
Okay, so let me try once again. Is it okay?
No.
No, the same thing is coming. Same screen sharing has failed to start. Why it is so? It should come.
Yeah, it should come easily, but.
So should I leave and rejoin? Then maybe it will work. Okay, so let me start once again.
Oh my God. How does it come?
So is there any technical problem?
Yeah, it's some technical problem is happening. Ellen is joining once again. He has already joined. Wait for a minute.
Same problem occurring. Is not shareable.
Wait, sir. Wait.
Okay. Check from your side.
Try again, sir. Try again for a.
Yes. But the same error code 105035.
Sir's video is put off, I think.
Yes.
Sir's video. Yes, sir.
Oh my God.
No, it is not coming. Not coming, so I can go from my side, but you can't see it. That is the main problem.
Partho, can you try once again?
No, I have tried.
Once again, Partho.
Sir, please try once again.
Okay. The same error is showing. Same error is showing. You can see, na? Nothing is visible.
No, sir. No, sir.
No. Basic.
Partho, LNS is seen as co-host. Is it right?
Okay. Yes. I have already making co-host. Okay. I'm making LNS host.
Not coming. Same error. Same error is coming. Just a second.
Sir, you are host now, so you can share your screen easily.
Yeah, it should come, otherwise, but it's not coming. There is some problem. I don't know, somewhere the problem is there, but I should continue, I think.
Yes,
with the
sir.
presentation, but you can't see the presentation. That is the main issue.
Yes, sir.
Once again. Computer. Not coming, no?
No.
Okay. So sorry. So let me speak from my side. So you can't see it actually, and I have to prepare the canvas from through my words. So climatology of tropical cyclones. Whenever we talk this, that our approach is very much geographical. So the difference between the meteorology and climatology is that meteorology actually it tries to understand from the physical processes, but our concern is more on the geographical areas. So where they occur and how they occur. So this many photographs are coming from the affected areas that we found during the Ayla and also during Amphan. But due to the lockdown, the situation was quite worse this time, because at one time there should be physical distancing has to be maintained, and on the other side there must have rescue operations. So this was a very, very big challenge for Amphan, but which was not for Ayla. But for Ayla also there was certain problems. The difficulties was that at that time the monitoring system was not that good. But this time the meteorological department, IMD, has very clearly forecasted the track with a considerable lead time so that the damages could be minimized. I could show you the geographical regions of different climatic types in the world. And in the tropics, where the India is located, the Indian subcontinent is located. If you see, go through the latitudinal extension, that much of India is beyond the Tropic of Cancer. But due to the presence of the Himalaya and two water bodies, one the Arabian Sea and the Bay of Bengal, the geographical location has given Indian subcontinent a character of truly tropical and mostly humid tropical. That's why, although it's much of area is lying well uh, beyond the Tropic of Cancer, so we may call them extratropical region, but geographically it is very much tropical. So weather and climates are basically consisting of both normals and extremes. So normals are those for which the occurrences are frequent. And cyclones occurrences are not that frequent compared to many other atmospheric events. But geographically, cyclones are very much normal in the northern part of the Bay of Bengal. It is definitely not normal in the western part of India, particularly northwestern part. So cyclones are very common and part and parcel of the weather systems or climatic features of the Gangetic Delta region. So whenever we are thinking about cyclones and to mitigate the cyclonic hazards, so we have to take into account that cyclones are part and parcel of this landscape. The tropical cyclones, they are generated on the oceans, but they travel towards the lands. It is not that they travel by themselves and whatever they wish, they can go to either north or west or to east. It is actually the tropical circulation system, the presence of the Hadley cell, the easterlies and westerly winds, which are called the tropical circulation system, and some of the semi-permanent features of the atmosphere. We have to understand that the stable atmosphere is just an atmosphere consisting of the different elements from nitrogen to water vapor. But whenever the water vapor increases and with that the latent heat and it also increases, then the low pressure system develops and wind also changes. And in this way, when the sun is almost over the northern part in the northern hemisphere, particularly over the Tropic of Cancer, then the subtropical high, this region, it shifts towards north and sometimes north of the Himalaya, from where the westerly jets, they flow from the southwest to northeast or east. And during the summer, particularly the late summer, then this actually facilitates the winds to come from south. So the monsoon comes because of this shifting of the subtropical high towards north. And the subtropical high region at the lower level becomes a trough. So this is the basically atmospheric scenario that facilitates the cyclones to come. It is not that cyclones can come by their own. So the total atmosphere and atmospheric circulation system is a very gigantic system, in which the different types of weather systems, one of them, the cyclone, is a very large one relatively, but that is also embedded for a few days, and its tracks, its magnitudes, and all that associated with the features and its cloud systems, they are very much governed by the location of the subtropical ridge, or we call the subtropical high. This could be very interesting to show that during the northern winter, the high pressure region lies over the Tibetan Plateau and also over the northern extratropical part of India. But during summer, it is reversed. So low pressure is developed, and this facilitates coming of the monsoon. And prior to monsoon, the cyclonic storms, and also in the post-monsoon season, some of the cyclonic storms, they come with the reversal of the monsoon wind, or rather retreat of the monsoon winds. It may be noted that actually throughout the world there should be two types of climates. One is the summer, another the winter. But in the summer in Indian subcontinent, when rain occurs, that we call the rainy season. Cyclones, basically the tropical cyclones we are talking about, much of the tropical cyclones, and maximum rather, they occur with high intensity or magnitude in the West Pacific region and also in the West Atlantic region. In that sense, the frequency and magnitudes are less in our northern Indian Ocean, but the Bay of Bengal region is very favorable. Why they are not so prominent and not in number? Because the extent of the ocean on which these cyclones should develop, it is comparatively less, very small compared to the other oceanic areas. Over the Indian Ocean, IMD had released a E-cyclone atlas showing the 1891 to 2008 cyclonic tracks and the records, where it has been found that out of 618 cyclones, 485, almost 78% formed over the Bay of Bengal, and only 22% in the Arabian Sea. Why the Bay of Bengal region is favorable for the development of the cyclonic storms? Because it is highly enclosed. This is number one. Then, because of this enclosure, the sea surface temperature can increase a lot. And in this Bay of Bengal, the ocean currents, they also generate to flow two directions. One is from south to north, northeast, another from north to south, southwest. So this reversal is very much related to the energy balance on the sea surface temperature. And you know that to generate the genesis of the tropical cyclones, its requirement is more than 26.5 degrees Celsius of sea surface temperature. But in the pre-monsoon summer season, it went up to 29 degrees, around 30 degrees sometimes. It may be noted that many cyclonic storms, they generate on the Bay of Bengal. In their embryonic stage, they actually dissipate it. They cannot form as a cyclone. Rather, they form as a cyclonic disturbance or tropical disturbance. But the rotational speed is not achieved to more than 62 kilometers, so that it can be designated as cyclonic storms. And Coriolis force is required, so it should be above 5 degree equator of the equator, and much of the Bay of Bengal is basically beyond 5 degree from the equator. And another very important thing is that the vertical wind shear. That means if a cloud has to fall over a vertical system of around 10 to 20 kilometers, if there is strong wind horizontally, then that will be broken. So it is called wind shear. During the monsoon season, the wind speed is more, and that's why the tropical cyclones cannot generate. Only we find depressions. But during the pre-monsoon and post-monsoon seasons, the horizontal wind is less compared to the vertical ascent of the winds, in situ winds. So that facilitates very good development of tropical cyclones. The scales are very important, that we call them low pressure area if it is only about 32 kilometer, the rotational speed. Then up to 60 kilometer, it can be from depression to deep depression. And from there, cyclonic storms from 60 kilometer to almost 220 kilometer with different categories like severe cyclonic storms, very severe cyclonic storms. The Amphan was basically very severe cyclonic storm, and Ayla was a severe cyclonic storm, and super cyclonic storm. The Odisha 1999 cyclonic storm was basically a super cyclonic storm. Again, we must understand that in a single cyclonic system, when it develops over the ocean, it starts with a low pressure area, and then become depression, and then become cyclonic storm, and then with the energy and rotational wind speed, it becomes supercyclonic storms also. But at various stages, wind speed changes, and accordingly, at different locations, they may be either cyclonic storm or very cyclonic, severe cyclonic storm. So when the Amphan was approaching towards landfall, it was a very severe cyclonic storm. But when the landform occurred, then it became severe cyclonic storm. And then after that, on 21st, it became cyclonic storm. So then it died down. The structure of the cyclonic storm is a very gigantic, with the vertical development of around 15 to 18 or sometimes 20 kilometers. But it depends that not all cyclones have the same vertical altitude. So in that sense, if the vertical growth is more, definitely it has the potential to become more dangerous and sustain its energy. And by its width, the diameter is around 500 kilometers. Sometimes it may go up to 1000 kilometers also. But the larger the size, sometimes it may sustain, but the speed may be low. And in the cyclonic system, not everywhere the same type of wind speed will be found, because there are certain bands or spiraling motions like cylinders. And at the center of the cyclone, we call the core or eye, the speed is the lowest, and also at the periphery, it is almost lesser. But in some bands near the core, the wind speed is very, very high, and at sustainable speed of around 3 minutes average, we call them as the gust wind or gusting wind. So this gusting wind may increase very severe cyclonic storm when the entire cyclone is actually a severe cyclonic storm. So with the funneling effect, sometimes if at a broader area, the storm rotational wind is entering and it is exiting at a narrower passage, then the wind speed may increase up to 220 to 250 kilometers. And those are very, very dangerous. But our concern in the cyclonic storm is that we are interested about the lower part of it within a depth of around 100 meters. But the cyclone has a depth of 15,000 meters. So it is a very less in the lower part. And definitely due to the frictional forces at the lower part at different places, the wind speeds are different. And if you see in the Sundarban region, in the Himalayan or maybe in the eastern part of Sundarban, then you can find that at some places, due to winds, very high wind speed, the losses are more, damages are more compared to other areas. So the differential wind speed at the surfaces, they are very much common in the cyclonic systems, that everywhere not the same speed. Then if you see the tracks of the cyclones that has been plotted by IMD, most of the storms, their tracks are from, I am talking about the Bay of Bengal storms, they are going from south to west, northwest. Some of them have crossed the India and again reinvigorated to become cyclonic storms in the Arabian Sea also. But in most of the cases, they either the track first go towards north, then to northeast or northwest. And there is a divergence. If I pinpoint Kolkata particularly, then if the line of the meridian and the longitude and latitude, they cross at a point, then you can find that there is the divergence. Most of the cyclones, they have towards tracks towards east, and most of them, the other parts towards west northwest. So the northern part is very rarely affected, and that's why our northern districts are simply not affected. So coming from northern part of South 24 Parganas, then North 24 Parganas, and our Nodia and all that. So they are very infrequently affected by the cyclonic storms. Only Ayla went straight, and also Amphan to some extent, but then again it recurved towards east. But this is the situation. But why this is so? This is so because I talked about earlier that the location of the subtropical ridge, this is very important. So whenever it shifts towards north, then the westerlies are more vigorous, and then there is a every chance that it moves towards east. But if it is at the lower level, at lower latitude, then there is every chance that the cyclone is going to retract it towards west. So the Odisha to Tamil Nadu, these coasts are then mostly affected. And regarding the post-monsoon cyclones, the southern part of Indian coast, they are mostly affected. And in the northern part, in the Bay of Bengal and all that, the depressions are very, very common. Cyclones are not that much common, but it is not uncommon also. One more thing is that cyclonic storms, their numbers are not increasing that way, but the severity or the high magnitude cyclones are increasing. So that is more matter of concern, because with this we have to, our adaptive capabilities have to be redesigned to cope up with large magnitude cyclonic storms. In case of Bay of Bengal, this is more prominent than the Arabian Sea. Then coming to the naming of the cyclones, the tropical cyclones, cyclones are occurring since time immemorial, but then there was no name. Since 2004 September, in the North Indian Ocean region, the cyclones are given the names. Earlier, you can find that Odisha super cyclone has no name. Otherwise, there should be some name. So some organizations are there of World Meteorological Organization, particularly the Tropical Cyclone Warning Center and Regional Specialized Meteorological Center. They actually propose the names, these RSMCs. And earlier there were 8 countries and 8 of them they gave 8 names, and from the column 1 in the row 1, the name started with O'Neill and it ended with Amphan. So in the first list has already been exhausted, and the most of the notable storms are like Ogni, Sidar, Nargis, Ayla, Laila, Philin, Hudhud, Okhi, Titli. Okhi occurred in Arabian Sea, Fani, Bulbul, and Amphan. But very recently, on 28th April 2020, IMD, this regional meteorological centers, they have proposed another 169 names. So this time, 5 more countries have come, and among them the Iran, Qatar, Saudi Arabia, United Arab Emirates, and Yemen. So now, out of 169 names, already Nisarga has come. It appeared in the west coast. And it is also a very important point, very interesting, that if the names are very vigorous or dangerous in their magnitude, then those names are permanently retired. That means they will never be used. So if they are very small, insignificant, they may be further used. This time, Amphan was actually named by Thailand, so one of the member countries. And the pronunciation of Amphan is actually Umpoon, like this. So Umpu, there should be several O's because the Thais, they pronounce it in this way. So the risks and vulnerabilities, they will be, I think, discussed by my co-panelists. But risks are always associated with the potentiality of the hazard, the vulnerabilities, and the exposure. So exposure in terms of the seasons, and exposure in terms of the geographical area, and exposure in terms of the number of population. And then their vulnerability means how they can cope up with it, whether they are resilient or not. And hazard, that means how many they are coming and what is their magnitude. So all these have to be taken into account to manage the risks, because everywhere risks are there. In the coastal regions, you know, most of the people are living in the coastal regions knowing fully well that the risks are associated with the land, because risks and rewards, if I make a ratio, then definitely if the risk is 1, the rewards are more than 1. So that's why people are living here. And if we can manage the risk, then definitely reward will be more. So government of India has a very good structure at different levels, and they supposed to have a functional administrative system from the National Disaster Management Authority to the local authorities up to the level of panchayats. And early warning systems are given by IMD. Earlier, the systems was not so good, but now from the space, we can find and pinpoint the locations of the development of the cyclonic storms. Earlier, it was not possible because the data were generated mostly from the points or the land-based systems, or maybe from the ships or buoys or balloons. But now satellite images, the radars, they can play a significant role in identifying the genesis to the tracking and giving the lead time, and finally with that the damage control exercises can be done. And if you go through the IMD websites, lot of data products are there, and if we can interpret it very nicely, because the interpretation of weather data is a very, very difficult thing, and that requires a huge computation, and ordinary computers cannot do. But the models are also running, and many models out of that ensemble model is working very good. That is taken by the IMD also. It has a very good lead time of more than 3-4 days. So it is quite good enough for the administration to relocate the people from the vulnerable areas. So with this, I stop here, and if there is any question, so we can discuss that. Thank you very much. Thank you. Hello. Hello.
Okay, okay, sir.
Yeah.
Pradipta. Pradipta. Pradipta, unmute yourself.
Yes.
Okay.
Yes. Thank you, sir. Thank you for enriching us with your knowledgeable speech. Sir has enlightened us about the detailed climatology and mechanism of cyclone formation in the Indian subcontinent. Though we missed the contextual illustrations due to some technical issues. So we are going to our next topic of discussion. So before that, I would like to request to Sir LNS sir, please, if you could stay until the question answer session, because so many of our students are listening to you, sir.
No, actually, my problem is I have to enter another webinar at 5 o'clock. Okay.
Yes, sir.
So
That is
there I am the
also
only speaker. So if the students can ask some questions right now, I can answer.
okay. So is it possible our host to take some questions for her?
It's possible. It's possible. Please proceed. It's
Okay.
possible.
So please, it's over
Thank
to our
you.
host to convey some questions to LNS sir.
Over to the participant. If you have any question, please carry on.
So I can
Please
see from
raise.
the chat box also.
All the participants are
You can
listening.
you can
They can
raise
write
your
on the
hand.
chat box also.
You can raise your hands, please.
Please raise your hands if any one of you have the question.
Okay, there is a participant Rinku Pal. I am just unmuting you. Rinku Pal, are you there? Rinku Pal, are you there? Rinku Pal, are you there? Am I audible to you?
Yes.
Rinku Pal, please proceed.
Yes, please.
Rinku Pal, you raise your hand.
Or
Do you have any questions?
Or you can write the question on the chat box.
Yeah, definitely.
I can see it from here.
Rinku Pal, if you can ask your question to our sir.
Mohammad Asghar Hussain, are you there? Mohammad Asghar Hussain, you raise your hand. Do you have any question? Mohammad Asghar Hussain. Mohammad Asghar Hussain, please unmute yourself.
Is there anybody else or from
Is
YouTube?
there anybody else?
বাংলাতেও করা যাবে, বাংলাতেও বলা যাবে।
দেবব্রত ঘোষ, দেবব্রত ঘোষ। Yes, yes, please. Dept.of, please carry on. Dept.of, please carry on. Dept.of, Dept.of, am I audible to you? You are unmuted already. Please carry on. Ansari Ghulam Rasool.
Yes, sir.
Yes, please proceed.
Yes, sir. I have a question related to this topic.
So my question is that the tropical cyclone is moved from east to west part. That is the direction from east to west. That is the wind circulation direction. As sir said, the tropical cyclone is generated that 23.5 degree north to 23.5 degree south. Now my question is here that. Is that possible? The tropical cyclone is moved from west to east?
Yes, it is possible. No, actually, one thing you see, uh, 23 south to 23 north, that doesn't mean that the cyclones originating from the southern hemisphere, they will come forward to the northern hemisphere. So whatever they generate in the northern hemisphere, suppose one cyclone generated over the Bay of Bengal in the south central part, it may go straight towards west to hit the coast, or it may go towards north to hit the northern part of the Bay of Bengal. So this kind of direction may be possible because of the location and the general pattern of the tropical circulation system. We call this as a general circulation of the trade winds, or maybe the easterly jets and westerly jets, and also the location of the semi-permanent atmospheric systems like the troughs and ridges. So they are very gigantic because a cyclone has its vertical development more than 10 kilometers. And the tropical circulation is also operating like a conveyor belt in this below this tropopause. And the tropical tropopause in summer, it moves up to 22 to 25 kilometers on the average. So enough space is there for the cyclone to move to the with the pattern of the general circulation. Okay, that is the main reason. And another point is that how the cyclone is sustaining itself. That means it has to feed on moisture. So wherever the moisture is available, to that area, it has a tendency to move. So in the lower level, it is guided by the moisture intake, and at the upper level, it is guided by the general pattern of the wind circulation systems. Okay.
So, Dr. Satpathy, there is a question from YouTube Live.
Okay.
Uh,
Okay, please.
Pintu Mondal is asking, what should be the ideal solution for climatic migration to cope the adverse effect of storm surge?
Question is quite confusing, but actually, mitigation of climatic hazards, it has two parts. One is that the origin of the hazards. Right now, whatever global warming has already taken place, we cannot change that scenario. Even if we stop all the activities of human activities of emissions and global warming, still it will continue to work for the next at least 1 century. So we are not in a position to stop the hazards, the cyclones. It is not possible. No mechanism is there. But we can minimize the loss through various adaptive mechanisms, and that I think from Ayla to Amphan in the comparative study, Sayantan and Nabendu are going to emphasis. So I'm not going to detail out that. But thing is that people are more resilient in these days, and more importantly, the IMD people, they can give the accurate forecast. So early warning system, it is a very important part of disaster risk reduction, what was promulgated in the Sendai framework in 2015, that by the year 2030, we have to substantially reduce the disaster risks. And early warning system is one of the very, very important tool. And our scientific community, they are doing wonderful uh, uh, things, because earlier up to Ayla it was quite unthinkable, and up to Odisha super cyclone it was quite unknown. Thank you.
So there is a
Sir, this
question.
is
Yes.
There is a question on chat. It's from Dibbodoti.
Okay.
Dibbodoti. I have a question, sir. Does the cyclones have any consequences on wetland ecology in Indian
Yes,
subcontinent?
definitely it has. Definitely, because the cyclones, when there is a landfall, if it is a very severe cyclone or severe cyclone, then the sea surface, the waves are generated, and the waves are high to the tune of around 4, 5 to even 10, 12 meters. And these storms surge, they strike the embankments in the coastal regions, and breaching of the embankments is a very common phenomena with the cyclonic storms and storm surges. And then the ingression of saline water, they will definitely adversely affect the wetlands of the coastal areas, not only the wetlands, but also the entire water environment, the agricultural environment, and the habitations. So negative impacts are very, very common with the high magnitude cyclones associated with storm surge. And these storm surge are also responsible for the coastal erosions at various points. So the erosions are very common, and I think Santon and Novendu, they are going to show the extent of the erosion environment.
Okay, thank you, sir. Mr. Devobroto Ghosh, do you have any question? You are raising your hand. Mr. Devobroto Ghosh, you are already unmuted. Do you have any question? You are raising your hand. Okay, thank you. Thank you. Over to Pradipta Mollik.
sir, this is Shahid. I have one question.
Yes.
Okay, please proceed.
Hello.
Yes.
Please proceed, please.
I have a very basic question. First of all, we have seen a lot of cyclones in these years, and most of the cyclones pass through Andhra Pradesh, Orissa. I mean, their main paths. After landfall, it passed through Andhra Pradesh or Orissa. Most of the times, we have seen that West Bengal has escaped from this.
Yes.
Okay,
Yes.
and many of the times, Bangladesh, the Cox's Bazar region, it has experienced a lot of uh, cyclonic storms. Uh, the main thing is West Bengal most of the times are, I mean, are not facing the same amount, same kind of intensive cyclonic storms as compared to Orissa or as compared to Bangladesh. What is the reason? This is a very
Yes.
basic question.
Yes. Yes. This is, you see, if you go through that time chart of the cyclones occurring in the Odisha coast or Andhra coast, then you can find that many of them, they occur during October, and some of them, they occur in the early May. Okay. But if you see the cyclonic storms occurring in the northern part, particularly in the West Bengal and Bangladesh side, then they are mostly in the September end, and also in the later part of June, or the mid to later part of June. So the timing is very important to correlate it with the location of the subtropical ridge. This location of the subtropical ridge and the at the low level, the troughs, they are very important to guide the cyclone to for its tracks. Regarding the magnitude, this depends on the factor that how much of fetch, that means extent of the sea surface over which the cyclones are traveling, and also the temperature, sea surface temperature at that point of time, that will give the moisture, because moisture is the main source of energy. And third point is that that is also associated with the location of the subtropical ridge and the lower level trough, that is this the wind, horizontal wind, because horizontal wind, if the speed is more than 10 meter per second, that will destroy the cyclone. So to remain as cyclone, the vertical wind shear has to be less. That means horizontal wind should be less. Uh, so these are some of the issues, and coincidence of all these factors are responsible for the associated strength of the cyclones and their tracks.
Sir, Pradipta Malik is asking what is the main reason of increasing thunderfall these days?
Increasing?
Thunderfall.
Thunder, sir, thunder.
Thunder, yes,
Thunder,
yes.
sir.
Okay.
What is the main reason could be?
Now, thunder, actually, you see, in the cyclones also, there are two parts. One, thunderstorms may be associated with cyclones or may not be associated with cyclones. Suppose the nor'westers or the kalboishakis, they are not related to cyclones. They generate in the eastern part of the Chodnagpur plateau, and then they travel towards east in search of moisture. Because in the Ganga Delta region or in the Bay of Bengal region, moisture is there. So they travel from west to east, and there are vertical updraft and downdraft. So in the downdraft, there is the cold wind, which is relatively heavier, and in the updraft, it is the moisture laden wind, which is the lighter. And there is a vigorous mixing at the top, and the system that travels at a very high speed, and with the high speed, actually in the updraft and downdraft, that is also very high, at a very high speed, and also at the top of the cloud, we call it a cumulonimbus cloud. The cloud actually moves faster, and the cylinder breaks, and with this breakage, actually the thunderstorms is generated. Then there are the mixing, the graupels we call lighter soft hails, they actually move downwards, and ice crystals, they move upwards. And at a level of supercooled air near, suppose at a height of around 10 to 15 kilometer, then this friction, they gives way to various ionization of positive ion and negative ions. So within the cloud, there will be exchange of ions, and that will cause a rapid exchange of ions that will cause thunder. And that thunder, actually, when pressure changes suddenly, the sound is developed. But very often it is found that positive ions are less compared to the negative ions, because negative ions are more in the lower part. Then that will draw either the positive or negative from the ground, and that will actually neutralize the entire cloud system. In the cyclonic storms also, these vertical cloud bands, I talked about that in the cylinders, there are certain cloud bands, and in the cloud bands, there are cumulonimbus clouds also. They're acting more or less similar to that of the thunderstorms. Then second issue is that whether the number of thunderstorms has increased or not, it is a questionable issue, because the reporting is more in these days. Earlier, the reporting was less, because now if there is any death from the thunderstorms, they are going to get from the disaster relief fund 2 lakhs. So and in the media and the police and WhatsApp group, social media also, they are very active in terms of the reporting. Earlier reporting was less. Some people, they tried to find a correlation between the atmospheric pollution in terms of the nitrogenous or hydrocarbons and the number of thunderstorms. But those studies are still quite incomplete. So far I know.
Dr. Satpathy, one of our participants is asking, one of our participant, Palguni Bag, is asking, is there any relation between tropical cyclone and El Nino?
Yes, El Nino, you know, if there is El Nino, that means the monsoon is going to be weak. Okay, because the wind that has to come from a very long distance. Our monsoon wind comes from thousands of kilometers away, far, far away from the southern part or south central part of the Pacific Ocean also. So in case of El Nino, there is a break at near the Australia, and the phase is low. That means the monsoon winds will be lesser, and there is a consequence that they may be leading to more cyclogenesis, that the conducive atmosphere circulation over the northern part of the Indian Ocean. But this El Nino is not the only thing. There is also this Indian Ocean dipole, because there is in the western side and eastern side negative and positive anomalies are there, and these anomalies are also very important in terms of development of the cyclogenesis as well as the monsoon currents. So this is a very complex situation. Yes, please.
Okay, thank you, sir. Thank you, sir. Over to Pradeep Tamalli.
Is there any question, Partho?
No, no, no hands there. No.
So it looks like we don't have any questions right now. So thank you, sir. Thank you for your valuable time with us.
Okay, thank you very much.
Thank
Welcome.
you.
So I am leaving for the next meeting. Okay, please.
Okay, sir. Thank you,
Please,
sir.
please don't mind. Okay.
Okay, sir. No problem. So now our next topic of discussion is comparing cyclone Ayla and Amphan estimation from remote sensing sources. So I would like to invite our next eminent speakers to share some thoughts with us. We have today Mr. Nobendu Shekhar Kaur, Assistant Professor, Department of Geography, Shohid Matongini Hajra Government College for Women, and Dr. Shayantan Das, Assistant Professor, Department of Geography, Domdom Motijhil College. Welcome to both of you, sir. Sir, please. Over to you, sir.
Okay, so myself, Shanton, and my co-worker is Novendu. This is a collaborative work. The other co-authors are Abhijit Das, research scholar of Kolkata University, and Professor Sunanda Bandyopadhyay, professor and head of Calcutta University. So I will just share the screen now, and please let me know if my voice is clear or not.
Yes, you can share.
Hello.
You can share. Yes, you can share the screen right now.
Okay, my voice is clear or not?
Sorry.
Yes, you are audible. Audible. You are audible.
Okay. Okay. So thank you for everyone's questions. I will start my presentation of comparing the cyclones Ayla and Amphan, and we have used remote sensing sources for this. And as far as these two storms are concerned, why these two storm events are compared? First of all, Ayla and Amphan. If you see the recent history, these are only two storms which cross exactly through the southern part of Bengal in a straight way, in a straight path. And if you see the other storms, most of the storms have moved through Orissa, through Andhra Pradesh, through Bangladesh. Of the recent history, if you consider the recent history, these are the two most important storms as far as the effect of the cyclonic storms on West Bengal is concerned. Okay. Now, starting with Amphan, because Ayla, I'm starting with Amphan because Ayla, the situation, the effects will be shared by Nobendu. I will talk about Amphan. Now, the first slide you can see here, the development of Amphan cyclone. This is the image of 17th of May 2020, and you can see the well-defined eye development here. And on the left-hand side, if you see my mouse hovering over this line, this white line, can you see the mouse? Can you see the cursor?
Yes.
Okay. So this cursor I'm showing you, this is basically the eastern coastline of India. And this is approximately the location of Chennai. And you can see here a well-defined eye was formed right in the Bay of Bengal. And it is just in between the Andamans here on the right-hand side and between Chennai. Okay. So this was my first slide, and you can see how the system has developed. Now, on my next slide, this is basically a cumulative track map of all the North Indian oceanic cyclones since 1970, although I have not included the last 2 years data into it. Okay, so this is basically the data found from National Oceanic and Atmospheric Administration of USA. And you can see the intensity, not only intensity, the amount of storms developed in Bay of Bengal is much higher, much greater in number as compared to the storms developed in the storms developed in Arabian Sea. Okay. Now, why Bay of Bengal has seen so many storms in the recent history? First of all, Professor Shotpati has already told a lot of things about this. I will technically I will tell about two conditions. First of all, the sea surface temperature of Bay of Bengal uh, during the summertime as well as the post monsoon time, this is much higher than the Arabian Sea. So this is one precondition which perhaps clear the way of development of a cyclonic storm. And the second thing is the Bay of Bengal's proximity to the Pacific Ocean. Now, the cyclonic storm development, most of the moisture sources are coming from the eastern side, that is from the Pacific Ocean. And from Pacific Ocean, Bay of Bengal comes first. And because of its bay-like shape, uh, the cyclonic storm formation is very easier as compared to the Arabian Sea. Okay. Now, in the recent history, both the areas have seen both the Arabian Sea and Bay of Bengal have seen many of the cyclonic storms. If you see the development of Cyclone Titli and Cyclone Luban in October 2018, as you can see here, almost at around the same time, these two cyclones were developed. Now, the difference is the Cyclone Titli, it was formed in the Bay of Bengal and moved towards India. On the other hand, Cyclone Lubal, it affected Oman and UAE, this region, mostly as compared to India. Okay. Now, another cyclonic storm formation, Phony. We all know about this Phony cyclone that occurred in May 2019. And you can see the Phony cyclone position near the Odisha coast here. And it made its landfall near Gopalpur in Odisha. And on the right hand side, you can see the cyclone Bulbul. This is the image of November 2019. This is the Aquamodis Terramodis image of 2019 November, and you can see the cyclone Bulbul, for which the landfall occurred through Orissa, northern Orissa coast, and through Midnapur, Purva Medipur. Okay, and this is our cyclone Amphan's image, and this is the development in 18th of May 2020, and you can see the clear eye formation or the core formation of the cyclone. Now, some basic characteristics, what we have observed for cyclone Amphan. Now, this is the first super cyclone to form in the Bay of Bengal since the Orissa super cyclone happened in 1999. And it left a devastating impact on the lower deltaic West Bengal as well as in Orissa and Bangladesh. Now, the general perception regarding this super cyclone is yes, Amphan was a super cyclone. Now, what common people thought about it, because it was probably, I mean, it was advertised. I would say it was rather advertised in the media that this is a super cyclone. Okay, now people have thought about it. Yes, we are experiencing super cyclone, but it was not the case because when it made its landfall, it became a very severe cyclonic storm. The super cyclone, the status super cyclone, it was attained when the cyclonic formation was in the Bay of Bengal. As compared to the 1999 Orissa super cyclone, the super cyclonic storm formation occurred inside the Bay of Bengal. Rather, in case of Orissa super cyclone, the super cyclone status attained very near to the landfall. And because of that, the 1999 super cyclone was much more severe than this one. And second thing is about the landfall of this cyclone Amphan. Now, there is a confusion regarding the landfall location, and many sources have talked about many places. We have taken the most authenticate source, which we felt that is the source of IMD, Indian Meteorological Department, and they say that this Saptamukhi estuary, this was the location of landfall of this cyclonic storm Amphan. Okay, and it is located about 100 kilometers, exactly 100 kilometers south of Kolkata, and it occurred around 3:30 p.m. in the afternoon and 4:30 p.m. in the afternoon. And Amphan causes massive damages in the districts of South Chobbish Pargana, Purba Mednipur, North 24 Parganas, Kolkata, Hooghly, Howrah. So these are the districts which are falling under the lower deltaic West Bengal part. And apart from that, two other districts, the southern part of Purba Bardhaman and Nadia districts were also got affected. And many houses were fallen, and millions of farmlands as well as many infrastructural things were grounded, and devastation occurred everywhere. And not only the countryside, Kolkata municipality area was also affected severely, as well as the Sundarban region. Now, talking about the development of this storm, if you see the storm system, now these three panels are basically depicting three different days, and these three panels are latitudinally correct. You If you see the position of Visakhapatnam here, and if you see the cyclonic formation around Visakhapatnam, uh, you can easily visualize how the storm system is moving towards Kolkata or towards the main land of India. Okay. Now, talking about the cyclogenesis of Amphan cyclone, this is the Terra Modis image of 14 May 2020, and this is the image taken at around 17:30, that is 5:30 p.m. And you see here the cyclonic system was developed as a convective low pressure system in the southwestern Bay of Bengal on 13th of May 2020, and it showed a potential for development of a mighty tropical cyclone, although there is no specific eye or core formation observed here. If you see the next image of 15th May, uh, 15th May, and here you can see that the system moved towards western side. Okay, and there is no specific eye formation again in this image. Now, on 16th May, the system rapidly turned into a depression. Now, what is the depression? You can see the wind speed here. It is depicting the depression condition, and it moved exactly between Chennai and this Andamans. Okay, and you can see the system intensified on 16th of May. This is the image of 5:30 in the morning, and within 12 hours, it transformed into a deep depression system with a maximum sustained wind speed of 56 kilometers per hour. So this is the range of deep depression system, 51 to 62 kilometers per hour. Now, talking about further development, the eye of the cyclone, you can see the eye of the cyclone has shifted towards northwest as compared to 16th May. Okay, and this is the image of 8:30 hours in the morning, and this has now strengthened into a cyclonic storm formation. Okay, and quickly moving on to the next slide, and you can see the system within 24 hours rapidly transformed into a super cyclonic storm. Now, if you see the color codes here, which are depicting the eye movement, cyclonic eye movement, and if you see the wind speed changes, you can easily visualize the condition how quickly the system has transformed. And this is the red color is marking the super cyclonic storm formation, and this is the maximum speed which we have observed was more than 221 kilometers. In fact, it is 222 kilometers per hour. The maximum speed was observed, and the sustained wind speed reached the maximum on 11:30 p.m. at night on the very date of 18th of May. Um, it was 241. It was 241 kilometer per hour. Okay, and if you see the next slide, 19th of May, it is still continuing as a super cyclonic storm formation. Okay. Now see, the system has moved near Vishakhapatnam on the north, and the system has gained more speed as compared to the previous days. Okay. And this is the situation in the next day, that is the day of the landfall. And around around noon time, the system was very near to the Sagar Island of West Bengal, and you can see here the system has decayed a bit. I mean, uh, earlier it was a super cyclonic storm. It transformed into a very severe, extremely severe cyclonic storm here throughout this path, and then again it changes into very severe cyclonic storm, and it made its landfall around 3:30 to 4:30 p.m. in the afternoon, and it was having a forward movement. The entire system was having a forward movement speed of 17.3 kilometers per hour, and the entire movement path was towards northeast. Earlier, when the cyclonic eye was formed, it was towards west or northwestern side, and now you see after the formation of this super cyclonic storm, it moves towards northeastern part. And now, if you see the next image of 21st May 2020, now you can see how the cyclone has moved through the lower deltaic West Bengal and through western part of Bangladesh. And initially, it was moving towards north, and afterwards it changed again its path towards eastern side to move towards the northeastern part of India. And near Meghalaya, the system ended. Okay, on 22nd of May, I have not shown the satellite image here. Okay, now Amphan's entire passage through Bay of Bengal occurred through the low tide time. Okay, throughout the low tide, and no new moon or full moon condition can be visible in these days. Now, because of these reasons, the storm surge elevations were not exceptional. Now, in case of Ayla, Novendu will show you, the storm surge heights were exceptional. It was more than 4-5 meters than the normal, because Ayla coincided the highest high tide situation in the new moon. But in case of Amphan, there were no new moon, or there was no new moon or full moon condition, and it was coincided with the low tide times. So that is why the storm surge height was only 1.98 meter higher than the normal situation on 20th of May. So that is why the storm surge height was not significant. Height was not significant. Now, if you see its movement, the eye movement, we have accumulated all the eyes of different dates and different times, and all the eyes were color coded to show you how the intensity of the storm has changed. So it is moving from a depression on 16th of May, and it changed into a super cyclonic storm on 18th of May, and on 20th of May, it made its landfall on the southern part of Bengal. And on 21st of May, at around 1 p.m. IST, Indian Standard Time, the system has decayed completely. So, starting from 13th of May, ended at around 21st or 22nd May. So, it was a life cycle of around 9 to 10 days for Amphan. Okay. Now, talking about the effect of this cyclone. Now, if you see this particular slide, now on the left hand side, this image is basically not only this image, all the panels are basically showing the background image of Sentinel 2A, that is the optical remote sensing image having a spatial resolution of 10 meter only. On top of that, we have overlaid the data what we got from the radar images. Now I'll go to this later on. First of all, we will see how the storm path has changed, how the storm path has moved. So this is the landfall location in the Shaptamukhi estuary. You can see where my mouse is hovering. Now it is moving towards northeastern location, the eye. If you see the buffer of the eye, if you consider 20-kilometer buffer of the eye, so it is including the eastern fringes of Kolkata. Now, the people, the participants who are residing in the eastern fringes of Kolkata, like in Barasat, in Modhumgram, Damdam, Rajarhat, Salt Lake. So these are the areas the residents have experienced that initially the storm uh, was coming from the northeastern side. Okay, the cyclonic storm was coming from that side, and the wind speed was extremely high. Uh, if you consider the situation of an urban area, so the wind speed of this particular cyclone recorded in Damdam at 7:30 p.m. on 20th of May, as far as I can remember, was 133 kilometers per hour. Now, the maximum wind speed was recorded at around 157 kilometer per hour, with gusting wind of 185 kilometers per hour. Now, talking about the eye movement, so it continued around Kolkata. It continued uh, near about until near about 8 o'clock. Okay, and after that there was a sudden lull period of around 30 to 45 minutes, and I I can remember people came out of their houses to see what kind of damages were done, and all of a sudden the wind started to come from the opposite direction, that is from the southwestern direction. So this is the typical condition observed within the eye. Okay, so first it was coming from the northeastern side, and then after half an hour or 45 minutes of calm condition, it was coming from the opposite side, that is from the southwestern side. I think most of the people in these areas have experienced this, and it continued. The second gust of wind was continued for around 2 hours. Okay, so how these data were generated. First of all, we are talking about these inundated areas which were color coded, which are color coded in dark blue shade, and the permanent water bodies are color coded in light blue shades. Okay, the sky blue, you can say. Now these permanent water bodies are basically representing the very areas, that is the aquaculture farms. Okay, so most of these farms you can see here, most of these farms are located in the North Chobbish Pargana and South Chobbish Pargana districts, as well as some farms are there in Purba Mendipur also. Now these are very low-lying areas, and these permanent water bodies are common throughout the year. Okay. Now, if you see the amount of the amount of inundation, you can see the maximum amount of inundation occurred in these regions. Okay, the Hooghly estuary region, especially the region where the Rupnarayan and the Hooghly rivers meet. Okay, now how these data sets were extracted, how these permanent water bodies and inundated areas were extracted. First of all, I'd like to say that most of the images, if we consider for our remote sensing based studies, most of the images are optical images. For example, we talk about Landsat images, LIS 3 images, LIS 4 images are there, even Sentinel 2A, 2B images. So these are all uh, passive remote sensing images because they are using the source of sunlight. Okay. Now talking about these radar images uses their own source of light, and basically these are catching the radiation from the ground. Uh, so because of that, uh, cloudiness or cloud obscurity cannot affect this kind of images. The optical images are extremely affected by cloud formation, and the radar images are not affected by it. So therefore, if you want to show the inundated areas, so this is the best way to represent with the present technology, that to use radar images. Now we have used the Sentinel 1A radar images. First of all, we radiometrically calibrated these images, and terrain correction were done. And after that, we have used this thresholding method, histogram thresholding method, to differentiate between water class and non-water classes. And these water class pixels were converted into vector. First of all, it was raster image, and after that, it was converted into vector. And this can be done through any standard remote sensing software. And after that, these vectors were overlaid on these optical images to see which areas are permanently waterlogged throughout the year, and which areas are inundated for this particular storm event. We'd like to keep it in mind that for this thresholding, particular thresholding method, we need to take into account very closely spaced images, time spaced images, because you are taking into account a storm event. So you need to take an image, a radar image before the storm event and after the storm event, and you need to use the same threshold value to differentiate between water and non-water pixels. Otherwise, the work will have many errors. Okay. Now talking about specific areas, now this B panel is basically representing the NSCBI airport or the Kolkata airport, Netaji Subhash Chandra Bose International Airport. So you can see the amount of waterlogging occurred in the tarmac area and the runway. So it is completely underwater, and this is the data of 22nd of May, 2 days after this Amphan storm. And if you see the images, these are taken from media sources. So this is the tarmac area of Kolkata airport, and you can see the waterlogged surfaces. And again, if you see the C and D, so these two areas are most waterlogged. So C is basically representing the Hasnabad block or the Sandeshkhali blocks. So these are the areas affected much by the Amphan storm, and still some of the areas are under inundation. And in the D image, you can see the meeting point of two rivers or three districts. And here, most of the areas are very low lying, and that is why the storm inundation was much higher than any of the other areas. Okay. Now you see this is a part of the Sandeshkhali block. So this is raster images. These are raster images. On the left hand side, this is the pre-Amphan radar image of 19th May, and on the right hand side, the post-Amphan radar image of 22nd of May. And these reddish patches on the right hand side, these are basically the inundated patches, and the blackish patches, these are the permanent water bodies. So you can easily differentiate by thresholding method these particular water and non-water areas. Okay. Now I will show some of the pictures of these particular cyclone related to this particular cyclone. This is of Najat of Sandeshkhali 1 block, and in this particular place, embankment toppling has occurred. This is not embankment breaching. The water has toppled this area to move towards right. Uh, you can see the inundation. These are some of the village site pictures. I'm sorry, something has happened here. So what is going on? Can you see the screen?
Yes.
Hello?
Yes.
Okay.
Please carry on.
Okay. Okay, something has happened to my end. Anyway, I'll go to the next slide. Still there is some problem. I don't know what is happening. Okay, I'll just. Okay.
Slide is
So this
back.
is the next image of.
Carry on, carry on.
It is coming. It is coming.
Yeah,
Yes,
it's coming.
yes,
It's coming.
it is coming.
Okay. So this is the area called Chokpatli in Hasnabad district, and this is the image of Pathor Pratima of South Chobbish Pargana. These images, and this is the situation in Gosabad. So you can easily gauge the intensity of this Amphan storm. So it was more intense than Ayla. And the last panel, panel E, this is basically representing the area of Sagar Island, Mosumi Island, and Namkhana Island. And you can see on the southern part of these islands, there is a lot of inundation. And these are the raster images again of 19th of May, that is 1 day prior to Amphan, and 22nd of May, 2 days after Amphan. And these red areas on the right hand side are showing the inundated patches. And now most of these red areas, the waterlogged areas occurred in the farmlands, okay, and low-lying areas. And this is the optical image. Right hand side, it is the post Amphan image, and on the left hand side, it is the pre Amphan image. So this is the situation of Mausumi Island on the left and Bokhali Island on the right, or Namkhana Island in the right. Okay. Now you see the situation of these two islands, and this was the situation 2 days after Amphan, and you have seen these images a lot of time in different media sources. This is the Kochuberia jetty breaking away. The main structure is breaking away in the Sagar Island of 24 Pargana during the storm surge. Okay. Now, if you see the district-wise inundation situation, now if you consider the total area of these 8 districts, 12.3% of the total area of these 8 districts were inundated by storm waters of this particular Amphan storm. And two coastal districts were most affected as far as the amount of area is concerned. One is Purba Mednipur with 1,809 square kilometer of inundation, and South 24 Parganas 622 square kilometer of area, although the percentage is much lesser if you consider the total area of South 24 Pargana, because we have not taken into account the core area of Sundarbans. Now, all the other districts except Kolkata, all the other districts are affected by uh, extreme amount of inundation. So, if you consider North 24 Parganas, 10.3% of the area, then comes Hubli, 9.5% of the area, and Howrah, 19.7% of the area were underwater uh, after this particular event. Now, I have told you earlier that maximum waterlogging has maximum waterlogging was occurred in the Hooghly estuary region and in the reclaimed area of Sundarban in this North 24 Parganas and South 24 Parganas areas. And all these areas were heavily flooded initially and damaged by the cyclonic storm. In fact, more than the flood situation, the infrastructural damage was much more severe. Okay, now going to the next slide. So this is the embankment breaching site of Gosaba, South 24 Pargana. So this is another problem occurred in the reclaimed area of Sundarban, because apart from the core area of Sundarban, if you consider the reclaimed area like Gosaba, Pathor Pratima, etc., now all these areas were reclaimed by placing the embankments, either earthen embankments or concrete made embankments. Now, if these embankments are broken, the storm water will go into the farmlands or in other areas. So there is always a chance of these inundations taking place for weeks or even for months. What happened during Ayla? Now, uh, just a moment. Now, if you consider this inundation, this embankment breaching scenario, so this peninsular-like formation is in the Sandeshkhali block of West Bengal of North 24 Parganas. If you consider the left image and right image is showing the post-Amphan situation. So you can see here the water logging, amount of water logging. Here on the next slide, the dark patches are again showing the waterlogged areas very near to the embankments, which are representing the waterlogged areas, the embankment breached areas or embankment toppled areas. And then on the next slide, this is the situation of Gosaba. And this tiny region, this has experienced a lot of water logging here. Okay. So this is my lake slide of Ganga Sagar, the Sagar Island, the southeastern part of Sagar Island. And this is again showing a peculiar condition. First of all, during Ayla occurred in, I think, on 24th of May 2009, and it brought in the monsoon earlier, as far as I can remember. Because of that, the inundation occurred for months. Again, there was another factor that Ayla coincided with highest high tide during the new moon condition. So these two factors affected these regions, especially the Sundarban regions, severely, because the inundation occurred for months, not for weeks, but for months. And because of that, the saltwater intrusion affected the farmlands. And for many years, I don't know whether these areas are fully recovered from that yet, but for many years, the farming activities were affected. And now, in panel A, you can see the image of 19 May 2018. Now, why we have taken the image of 2018? As you can see here, this is the image of 19th May. This is a Landsat image. Now, this image is basically representing the normal situation during this time of year. Now, on 2019, we got a cloud, you know, on the 2019 image, there was a lot of cloud. cloud cover, and as well as on 2020 image for obvious reasons. So we wanted a cloud-free image. So that is why the nearest cloud-free image of this particular season was 2018, was of 2018. Now, if you see the condition 2 days after Amphan, so this is a 22nd May 2020, a list 3 image. This is showing the amount of inundation, inundated patches. Now, if you see the condition of 24th of May, the inundated patches are lowered in number. You can see the intensity has lessened. The water is going down. Okay. Now, because of better drainage system and better canneling system, the water is going out. And again, in 8th of June 2020, almost there is no sign of inundation. So another reason, apart from the good drainage system, there is another reason that the Amphan, unlike the Ayla, didn't brought in monsoon earlier. So monsoon occurred around 10th June or 11th June, starting from 10th June or 11th June. So because of this, uh, there was 2 weeks of clear time of relaxation. So that is why this area has almost fully recovered from this storm event, and you can see that the storm patches are almost missing here. So these are basically some of the effects I have, I have shortened out here. And these two districts, South Chobbish Pargana and North Chobbish Pargana districts, have experienced a lot of cyclones and vulnerable to the cyclonic storm events. And because of a lot of embankments erected about a couple of centuries ago, now these embankments are also very vulnerable to these events. So it could be broken any moment if another storm event will come. Now, apart from Amphan, these regions have experienced major cyclones like Ayla or even Budbud, and more than the fatalities in terms of loss of lives, the socio-economic condition has extremely affected due to these storms. Okay, and talking about the effect in Kolkata, so this is the image of Baliganj Circular Road. On the left hand side, you can see the Baliganj campus of Calcutta University. This is the next day of Amphan cyclone, and this is a few days before the Amphan cyclone. This is the condition of Ravindra Sarovar region, and this is right after the Amphan cyclone. You can see the damage. Okay, and these are some of the newspaper reports related with both the Ayla cyclone as well as the Amphan cyclone. Now, I think Nobendu, my co-worker, will take over from this slide. So, Nobendu, are you here?
Yes. Hello. Am I audible?
Yeah.
Am I
Yes,
audible?
you are audible.
Okay.
Yes, you are audible.
Okay. As he ends with Kolkata, I am starting with Kolkata. So you can see from the newspaper reports, the aftermath of both in case of Amphan and cyclone, the situation doesn't differ. Okay, the same story the same story repeated again. Now, what has next, please, Shantanda? The what has changed? The change, as told by Professor Shatpati, that a level of preparation, the warning system, the cyclone preparedness by IMDA and NDMA, that has changed. Okay, you can see this is a report from the Down to Earth that the villagers in a Goshaba, it is a block of Sundarban, didn't know that Ayla was coming. Okay, even didn't know. There were no newspapers, no mobiles, phones, or like that. Those things, no means of communications were there in 2009, back in 2009. But next, please, Shantanda. And you say you sorry, the previous one, Shantanda. And see that the center mobilized the disaster relief mechanism nearly after the day that is 25th May, the Ayla occurred after, and in 26th May that the central mobilized the disaster relief mechanism, Next, please. But in case of next, please.
So there is a 4-5 seconds lag. You have to adjust to it.
Okay.
Okay.
No. So in case of cyclone Amphan, we are prepared, as Professor Shatpathy said, that we have improved in this sector much more, and we are now already leading in case of the evacuation and other things in all over the world. Odisha is gaining a status of the leader in evacuation, like that. Okay, so this change, only this change, that the timely evacuation and the preparedness saved lots of life. Next, please. No, so from the management perspective, I am coming back to the I am coming to the remote sensing perspective. Okay, the first general comparison is made between Ayla and Amphan. As you see, they both occurred in May. One was 25th May of 2009, and one is 20th May in 2020. And there is the landfall. The Ayla landfall was between 1:30 to 2:30 between, and the location was in Sagar. The main difference between the two, that at landfall, Ayla was a severe cyclonic storm, whereas Amphan is a very severe cyclone. That is the maximum sustained wind speed differ from them. In case of Ayla, it was 102 kilometer per hour only, whereas it is Amphan, it is 157 kilometer per hour. So the difference is around 40 kilometer per hour. One can say that the 40 kilometer, how much it is. In case of it is not, but I must say here that the damage is not linearly related to the speed. Damage is much more in case of Amphan. I can explain with a simple example, that Ayla was like a surprising fast ball bowled by Anil Kumble in between his spins, and whereas the Amphan was the fastest ball bowled by. Hello,
Yes, you are audible.
but I can't see the presentation, na.
Yeah, the presentation is not coming. Hello, Dr. Das there.
Yeah.
The
Actually,
presentation
there
is
was
not
some
coming.
problem from my end. Yeah, I know, because the broadband got disconnected. Okay, so that was the problem. So I'll again share the screen. Okay, just a moment.
Okay, fine. Take your time.
So from this slide, Novendu, on to the next slide.
Yeah, this slide. Okay. So okay, what I was telling, that in Amphan is like the fastest ball bowled by Shoaib Akhtar or Brett Lee, or no? And repeatedly Dr. Das told that Ayla was corresponded with high tide, and the death toll was greater than Amphan. And surprisingly, what we see, that because it corresponded with the high tide, the more 77, as per the government record, 778 kilometers of embankments in Sundarban.
It's just
Embankments in Sundarban literally washed away. Whereas 245 kilometer of embankments were damaged by the Amphan. Now, next, please. Before going to the detail of impact, I like to mention one or two things. First thing is, if you see these diagrams, you can see where it explains where the damage will be higher in case of cyclonic storms. In case of in any cyclonic storms, there are two types of winds at play. winds are associated. The first is called the steering winds. Steering winds is the regional wind system upon which the cyclone is embedded. Say the forwarding motion of the storm. Okay, and the second one is called the vortex wind. Vortex wind means the cyclonic wind, the circulating wind that is around the core of a cyclone. If you see in northern hemisphere, due to the presence of the Ferrell's law, we can see that the right hand of the cyclone are more damage prone, because here the steering winds and the forwarding motion combines, so the damage will be higher in the right hand side of a cyclone storm in case of northern hemisphere. Next please. Now see, there are two situations. If cyclones run along the coast, then the damage will be higher along the coast even, and if it enters inland like the second one, which happened both in case of Ayla and Amphan, the damage will be more in the right hand side. As you see that places like where the embankment breaching has happened, like the the Hingolganj, those areas were on the right of the cyclonic track of Amphan. Next please. Okay, now this is the eye of the Amphan, and this line is the Amphan track. You can see the whole Sundarban in case of Ayla was on the right side of the storm track. Next please. This is the base track data there that shows the wind speeds and other. I am skipping this. Next please. Okay, this is the wind speed, and you can see that wind speeds are mentioned in Kolkata, Panagarh, Barakpur, Sagar. That was the norm, that was the speed recorded by the ground stations. Okay, now this is the most important thing I want to tell, that when Dr. Dash was telling that the storm surges were not comparable to Ayla in case of Amphan. As you see, it was in Ayla occurred during the high tide, and if you go for the actual storm surge column, that it see that the storm surge was about 2 to 3 meters above the astronomical tide. Astronomical tide means normal tide. Normal 2 to 3 meters above the normal tidal level. Now the norm, what is the normal tidal level? Okay, first I like to mention that the 2 to 3 meters is not a joke. 2 to 3 meters means more than or near to 10 feet. So it is like a floor of a house. Okay, now first we look what is the normal tidal level in Sundarban. Next please. Now look at this picture. Now this is taken at a northern part of Goshaba. Now see, these islands were reclaimed at about 250 years ago, and tidal spill was restricted by these mud-built embankments. So the islands are lower, forever lower than the riverbeds, and no sediments were deposited in the islands, and the sediments were deposited in the river beds. So the river bed got risen, and it results into the rise of the tide levels. You can see the house or the lady is under the water if the embankment are lower in lower elevation than the water. Next please. Now if you have for explaining the situation, this is myself. I am a 6 feet tall male, so already the islands are below 1.5 to 2 meters. Now 2 meters plus 2 meters, so it is around 5 meters, 5 to 10 meter, 5 to 7 meters tide level storm surge that occurred during Ayla, because it coincided with the high tides. And next please. And if that surge occurred, and what you can see what was the result. Now compared to Amphan, you can see the physical damages. Physical damages are low in case of fire. Physical damages, that the infrastructure, various houses or the various infrastructures like electrical poles, they are not so much damaged by Ayla because the wind speed were low. But in case, especially in case of Sundarban, a huge area was inundated because of the embankment breaching. Now, when the Dr. Dash was presenting, he told about the inundations also in case of Amphan. But these inundations, I like to give a detailed view, because two types of inundations are there. First one is the storm inundation. Storm inundation means the inundation by high rainfall. Okay. In case of, you see that Howrah, Purbo Medinipur, these districts were also under inundation, underwater for 1 week or so. But these were the fresh water or the rainwater. But here the inundation is by the saline water, which has a long-term effect. Next, please. Now, okay, fortunately we have a TM thematic mapper optical image, not a, it is not a radar image, because what he shown that what he showed that Sentinel-1 was launched in 2014. The radar analysis were not so developed in 2009 or so. So this is, unfortunately, we, though clouded, we had a optical TM data of 26 May, just the day after of the Ayla. You can see that the blue patches, dark blue patches, these are the areas where the embankment breaching happened, and these were all underwater. Next, please. And for our study, we have selected a block, that is Goshaba. Next, please. And for your information, that more than 50% of the Goshaba was underwater. Now we tried a land cover land use change, simple land use change, to figure out the impact of Ayla. We from that during a year, you can see February 2009 to February 2010. Now you can see this is the pre-Ayla situation, that is 2009. Now on your left is the image in false color composite. It is the satellite, raw satellite image, and whereas the map, the land use map, is in the is your right hand side, and you see that map show the character of a typically reclaimed marginal island of Sundarban in winter. As monocropping is practiced, current fallow is high, and linear pattern or orchards coincided with the embankments. Here by forest, we mean the mangrove patches. They are generally found in the island margins. Next, please. Okay. This is the image of the next day after the Ayla. As you can see, the whole region was, almost the whole region was underwater, except some pockets. In inundated areas, only the orchards, orchard means orchards are grown on the embankments, on the inland embankments, they are only visible now. And see, that by remote sensing, the land use maps are prepared by a simple technique that is called supervised maximum likelihood classification. Whoever uses remote sensing, they know that. But with this simple technique, we are able to mark the breaching locations. Next, please. Now see here. The dark blue represents the standing water or flood water, and the cyan represents the river water or the tidal water. Thus, the river water is intruding in this island through beach sides. Next, please. Intruding. Next, please. Thank you. So this river water intruding is this island through bridge sites is clearly visible. Now, similarly, major bridge sites at 36 bridge sites were marked. Next, please. Now you can see in June, the water already dried up in some location, where in some areas water level went down, but in most of the places deep waters prevailed. The inundated area represents 3 classes. Please, next please. Deep waters, next. Shallow water, and next. And wet soil. An interesting scenario. Go to September, please. An interesting scenario was observed in September. The dried places seen in June again inundated under raised water levels by monsoon rains. Feeble embankments breached again. Some cropping was done in September. We knew it from a ground truth verification. That is a sear paddy, a salt resistant variety. Next. Okay. Previous one, please, on the October one. Okay. Now, this October image shows a major part of the land dried up, resulting into fallows. Now, 2 types of fallows are identified. First one is, next please, moist fallow, and the second one is dry fallow. Next. As I said, some pockets were cropped, but it was a failure and yielded only a fraction of the normal years. Next, please. November image shows in nearly most of the region water dried up, resulting areas of moist and dry fallows. Still, some pockets seem to be inundated, especially in the eastern and southern part of Goshaba. Next, please. Now you can see in January, the standing water was completely desiccated. The region became barren with thin veneer of salt. Sorry. Next. Now coming to January 2010, the situation. Sorry. January 2010 images. Now the situation was very similar to the January 2009, but the only thing is that the soil becomes saline, the groundwater becomes saline, the water bodies become saline, and it was a completely mess up. It was a completely mess up. Next, please. Now, what Dr. Dash was telling, that that the impact period is very important in case of any hazard. The impact period in case of Amphan was 10 to 12 days as in most of the parts, as they were mostly storm inundation by rain. But the saline water inundation, as we can see in case of Sundarban, in case of this island of Sundarban, Kundaba, it went for a period of 1 year or more, and the effects and the islanders are also the islanders are also feeling the effects right today, as we have to compare Amphan with Ayla. So Ayla is like a benchmark. Ayla is like a benchmark of the damages. Okay, has become. Now it has changed changed completely the social fabric of the Sundarban. Several the poverty, it generated mass poverty, mass out migration from Sundarban, but it had some good results also in terms of cyclone preparedness. Communication system improved in case of whole Sundarban. The communication system has improved. The management system, disaster management system is much better today, with the presence of several storm shelters and plans. And because of the next please, because of the migration, we can see social mobility in Sundarban. That the main importance of that thing is the access of information has increased. We can see that in case of Amphan, one headmaster from Hingalganj sharing a WhatsApp message, and it was a hit in social media, and he received so many relief that later he announced in social media that no more fund is required. Okay, the access of information is a very strong tool nowadays that is available. And whereas we feel that, because in case of Ayla, the recovery period was very elongated, but in case of Amphan, we feel that the recovery will be much higher as they become more resilient. These days. However, coming back to remote sensing, that this exercise what we show, that the inundation of the storm events like Ayla and Amphan and subsequent recovery by generating large quantity of data may help in the pre, scene or post disaster management of cyclones. And plus it has an advantage that the information is completely objective. This is generated from space derived data. And I like to conclude with a note from the 5th assessment report of IPCC that more intense storms, so few in numbers, but more intense storms likely to occur in these sections, as told by Professor Shatpathy, in the future years. So we have to prepare for that, and we can see that if in all levels, in all ways of all stakeholders they associated with this, if they if they actively participate with a goodwill, nothing can be impossible. So we can manage, we can lower the rate of damages by effective management of cyclone. Thank you everybody. I like to thank the organizers and all the participants for hearing me and Dr. Dash. Thank you again.
Okay, over to Professor Pradipta Mallik.
Yes. Thank you, Mr. Kaur and Dr. Das, for your time and such elaborate, informative, and resourceful presentation based on satellite imageries and snapshots. It was our privilege. So now we will go ahead and take some time for questions. To all the participants, please be sure to type your question into the question box in your screen, and all the questions will be forwarded to the respective speakers by our host. So is there any question?
I can already see one question from Dept.of Banerjee.
Yes, please.
So he requested me to explain the threshold method again. See, depository, I don't know whether you are hearing this or not. It basically, obviously, it's a remote sensing technique, but this basically depends on how you are using the software. First of all, this particular technique, I have used the software. The software I have used is called Snap. Okay, so Snap is basically developed by European Space Agency, and in this software you have to use specific processes prior to this thresholding method. I have said this earlier. You have to go through this radiometric calibration as well as the terrain correction. So these processes you need to go through, and after that you will get the corrected image. Now, after you get the corrected radar image, what you need to do, first of all, you need to have the radar image of pre-event and radar image of post-event. First of all, you will see there is a histogram containing all the pixel values. Now you have to move a particular tool to see as you change these threshold values on the histogram. First of all, you will see two specific peaks in the histogram. Okay, two specific peaks like in bimodal distribution. Okay, so two specific peaks will be there. One will be for the water pixels and another will be for the non-water pixels. Now you have to differentiate it very immaculately. Okay, because it is very difficult to judge which one is permanent water body and which one is non-permanent water body. And for that, you need to have the optical image also, because the optical image of pre-event, it will show you which are the permanent water bodies are. Okay, it will clearly show you. Now, if you compare the pre-event optical image and the pre-event radar image, okay, now if you move the threshold values of the pre-event radar image, it will coincide at least after some time. I mean, after some trial and error method you go through, it will coincide with this pre-event optical image. Okay. Now the threshold value, which is coincided with this pre-event optical image, you have to note it down, and the same threshold value you have to use it for the post-event image. Okay. And by this particular method, you will get to know about the water pixel in the post-event image, because this is the only way, I think, only conventional way to find out which are the water pixels are. Now, there are specific manuals are given already in the European Space Agency website, as well as there are so many YouTube videos are developed for this particular exercise. So you can go through this, and it takes a lot of time. That is another point, and it requires specific, configured machines also, because a machine which is having less than 8 GB of RAM will not run this particular software. So you need to have a good computer. Okay. Any other question?
Okay, there is a set of questions from our YouTube participants. Dr. Abhishek Shah, assistant professor, he's asking how we can mitigate or minimize the waterlog problem using GIS technology after landfall process in Indian Sundarbans.
I think Novendu is in a better position to answer this question. He is working on Sundarban. Novendu, are you here? Hello.
He's muted, I think.
I think he's
Please
muted.
unmute. Please unmute.
Hello.
Okay, okay. You are audible.
Was host mute? Okay. Now see, GIS is basically for generating data. So you by GIS you can generate data about the embankments, where the embankments are, where the and you put the GIS data, you put the generate data and supply the data for uh, disaster management purpose. But the use of the data is depends on the authorities, how they will use the data. If I am asked that how the GIS data will be used, plus I will make an inventory of the embankment conditions of the islands. That inventory will tell us about the embankment conditions, the monitoring and the what are the conditions also, and the monitoring measures and the monitoring upkeep measures, uh, what upkeep measures are taken. These types of inventory can be made with the help of GIS. Which embankments are more erosion prone. This data set can be generated using GIS.
Okay, fine. One of our participants, Vishwajit Haldar, he's asking, is Amphan the biggest natural calamity to ever hit West Bengal?
If you consider the recent history, definitely it is the biggest storm. In fact, it is intensity-wise, it is much greater than Ayla. And previous data sets, if you talk about previous data sets, yes, there was an event occurred in 1737. Many people, many scientists, they called it as a big cyclonic storm event. Many scientists they told about this. This was it was an earthquake event. So there was no specific proof regarding that particular event. So if you consider the recent history, yes, definitely it is the biggest natural calamity. Uh, I'm not considering the fatality, I mean the death record, but in terms of loss, in terms of infrastructure loss, definitely in the recent past, if you consider, it was the biggest event.
One of our participants from YouTube Live, Muslim Hussein, is asking, sir, why did Tamil Nadu experience the least number of cyclone landfalls along the east coast of peninsular India?
Navendu, you or me? Navendu again muted. Muted.
Oh, okay. I'm just unmuting.
Okay, I think Professor Shatpathy has answered the question just previously, that there are a lot of factors that the seasonal factor, that is the sea surface temperature factor, the 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 high pressure ridges and low pressure troughs, that the embedded wind system. There are a lot of factors, the shape of Bay of Bengal. There are a lot of factors that is involved in the cyclonic track movement uh, Sometimes it is what I know, I what I read, that the normal they the IMD people, they built various models on that cyclonic track, and the most probable the cyclonic the most vulnerable states are Andhra Pradesh and Odisha. That means that Tamil Nadu not facing any of the cyclone. You can see there are various depressions, deep depressions. They landfall in Tamil Nadu, but cyclone generation is not that much compared to the northern states, because of those factors, maybe.
Okay,
Another
fine.
thing, I think you need
Another,
to consider the shape of the Indian peninsula also, because if you see the shape of Bay of Bengal, or rather the shape of Indian peninsula region, as well as completely, uh, I mean,
The funnel shape, the funnel shape.
from the Indian peninsula up to the Malay peninsula, if you see the complete shape, so as you go inside within the Bay of Bengal, the storm intensity increases. Now, if you consider the location of Tamil Nadu or Sri Lanka, these are right at the start of this region. So these regions are not likely to face that many of the cyclones. Okay, so that is another reason.
a participant named Ayantika Sen. Ayantika Sen says, please tell me the origin history of Sundarban.
Is it the right platform? I don't feel that it is the right platform
Yes, yes,
to
yes.
discuss the origin history.
I think this is not the right platform.
Please give her my email. I will send some materials. Or
And not only related with climate or geomorphology, it is also related with botany as well as zoology. So everything you need to take into account. So
this is
there
can
are a
be
number of
found
factors.
if
Soil is
you
another
just
important
search
factor.
in Google. This can be found. Okay.
Yes.
It's a bit
Somebody
high.
asked me about what is MODIS. So MODIS
Okay.
is Moderate Resolution Imaging Spectroradiometer. So this is the name of the satellite. Okay, it is just like any other satellite like Landsat or Sentinel. Okay.
Any other question, please? If the participants have any question, please type that. Okay. Okay, thanks. Thanks to all. Over to Pradipta Mallik. Over to Professor Pradipta Mallik.
So
Are you there?
yes, I'm here. So
Okay.
it looks like we have covered all our questions as of now. So now I would like to invite Professor Khushida Khatun of Department of Geography, Shohid Anurup Chandra Mahavidyalaya to convey vote of thanks. Over to Professor Khushida Khatun. Please unmute Professor Khushida
Yes, yes,
Khatun.
yes. Professor Khatun, you are unmuted. Yeah. Yeah, please, please proceed.
Yes, I'm here. Good evening, everyone. On behalf of the Department of Geography of Sri Chandra Mahavidyalaya, I take this opportunity to propose the vote of thanks to all who have helped us in making this webinar such a resounding success. Today, my words are not enough to express the gratitude. First of all, I would like to propose heartily vote of thanks to our distinguished speakers, Professor Dr. Lakshmi Narayan Sarpati, sir, for his valuable speech on climatology of the tropical cyclone. I also wish to express my gratitude to our another speakers, Dr. Sayantan Das and Professor Nibendu Shekhar Kaur, for making excellent presentation on comparing cyclone Ayla and Amphan and making this webinar really interesting and meaningful. I extend my sincere thanks to our beloved teacher in charge, Professor Gopal Devkanto sir, convener, Professor Nimai Poddar sir, IQSC coordinator, and Dr. Somnath De sir, who always stand by us, guide us, lead us, and motivate us. We feel proud and thank you for making us feel happy with your presence to this webinar. Thank you, sir. We also grateful to our technicians, Professor Parthopatim Roy and Dr. Arup Gain for your cooperation. Thank you, thank you, thank you. As no program can become successful with a single person, so I extend my big thanks to our teachers and office staff, not only from our department, rather also from other departments for our college. I heartily thanks to our participants for their active participation and took out valuable time of your busy schedule. Finally, our heartfelt thanks to our students for showing their interest in this webinar. Once again, I thank all for your cooperation. Thank you. Stay home and stay safe. Thank you. Rita.
Thank you. Thank you, Professor Khurshida Khatun. And one more reminder to the participants, please don't forget to fill up the feedback form that will be provided by us to get the certificate. So this is all for today. Thank you all. Thank you on behalf of me again. Thank you.
Okay.
Over to host.